Okay, we did a little bit of this last time, and that was write the rational expression in lowest terms. And remember, if you have 3x plus 6 divided by 3, you have, this is kind of like the distributive property for division. If you have two terms up here, you have to divide each one of them by 3. However, if you have 3x 6y divided by 3, now those you can do one or the other or any of them, but those you don't have to you don't have to do all of them necessarily. Like if you have 3xy divided by 3, you don't have to divide the x or the y, just the 3's. But if there's a plus or a minus in here, that means that you have more than one term and you have to divide all of it by that. So what we have to do here is factor. Now, if the linear term is negative and the constant is positive, it's going to be x minus something and x minus something. Okay, what are the factors of 10 that add together to give 7? That's going to be 2 and 5, huh? Come on, boy, think. Yep. 2 and 5. Negative 2 times negative 5 is positive 10. That's right. And negative 2 minus 5 is negative 7. So we're correct. Now, what can we do here? We can factor out a 3 out of here. And then we get x squared minus 25. And here you have a conjugate. It's the difference of two squares. So we have x minus 2 times x minus 5 in the numerator. And you have 3 open. Okay, again, this is a conjugate. So we have x plus 5 and x minus 5. Does somebody have a question? Okay. Now, what can all this is multiplication. So this is all one term. It looks like there's a whole lot of stuff in there, but it's not. Remember, the parenthesis makes this one number. So we have x minus 5 here, x minus 5 there. And so this is x minus 2 over. Now we typically would want to do the distributive property here. Multiply 3 times everything in here. 3x plus 15. Everybody okay with that? Okay. And let's see. Okay, let's do this one. B squared plus 6b plus 8 over b squared minus 3b minus 10. Now everything in here is positive, so it's going to be b plus something and b plus something over. Now the linear term and the constant are both negative, so it's going to be b minus something and b plus something. Now what are the factors of 8 that add up to 6? 4 and 2?
Yeah.
Okay. Now here we have the difference of, so what are the factors of negative 10 that combine together to give us negative 3? 2 times negative, well, that's it there, isn't it? 2 times negative 5. Negative 5 plus 2. Okay, now what can we factor out or reduce? B plus 2. B plus 2 is 1. Any number divided by, I've got a fly in here. Where did that come from? We may have to cancel class. I got a fly in here. Okay, b plus to any number divided by itself is 1, so that just cancels that out. And this is our answer. B plus 4 over b minus 5. Okay? Okay. Now, on to new stuff. Solving linear L-I-N-E-A-R inequalities. Q-U-A-T-I-E-S. Solving linear inequalities. Did I hit the record button? Yes, I did. How about that? Okay, inequalities are less than, greater than, less than or equal to, greater than or equal to. Now, if you have less than or greater than, we use parentheses. Less than or equal to, greater than or equal to, we use brackets. Less than or greater than, if I say that I have less than, if I have less than $10, what's the most amount of money I could have? $9.99, right? All the way up to 10, but not including 10. But if I say I have $10 or less, that's what less than or equal to means. And that means that I could have $10. Okay. Now we solve inequalities just like equations, with one exception. There's always seems like there's an exception. If you multiply or divide by a negative number, A-T-I-V-E. If you multiply or divide by a negative number, the sign flips. It goes from, instead of less than, becomes greater than. Less than or equal to becomes greater than or equal to. Okay? It's really very simple. You solve these just like equations. With that one exception. You multiply or divide by a negative number, the sign flips. Okay. That was one of your classmates. Okay. Again, we solve linear inequalities just like equations. So if we say that x is greater than negative 3, we're going to do 3 things here. We're going to solve it. This one's already solved. We're going to graph it. 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 5. Now, you can say this 2 different ways. You can say that x is greater than negative 3, or you can say that negative 3 is less than x. We want to say it really like this. X is greater than negative 3. Where's negative 3? Right here. Now, greater than, remember, greater than we use parentheses. Greater than will be all these numbers out to there. To the right is greater than, to the left is less than. And we also have a thing called interval notation. I-N-T-E-R-V-A. Interval notation. T-A-T-I-O-N. Now, interval notation mimics the graph. What's on the low side? What's the least this number can be -3. We use a parenthesis because it does not include -3. What's on the high side? What's the most this number can be? If the most that x can be? Positive infinity with a parenthesis because it does not end. Okay? Okay. Now what if we have this? 3a plus 2 is less than 17. Now again, we solve these just like equations. First we get rid of addition, subtraction, then multiplication, division. So we're going to subtract 2 from each side. 3a is, what is it, 15? And we divide by 3. Now we're dividing by a positive number, so our sign's not less than, stupid. Less than. Divide by 3. A is less than 5. Okay, the graph will look like this. Okay, here's 5. A less than, are we going to use a parenthesis or a bracket? A bracket. Less than, again, is this way. Greater than is this way. So it's going to be a bracket opening to the left. All the numbers that are less than 5. And the interval notation, what's on the low side? What's the least a can be? Negative infinity with the parenthesis because it does not end, and infinity goes on forever. And what's on the high side? What's the most it can be? 5, again with a parenthesis. Okay. -2b plus 3 greater than or equal to -9. We got all these godless negative numbers in here. Oh, this fly's pissing me off. Boy, you better get out of here. I'm going to kill you. I'll rip your wings off. Okay, again, we solve these just like equations, so we're going to get rid of the 3 first. And we have -2b on this side, greater than or equal to -12. Now we're going to divide by, if you fly by here one more time, now we're going to divide by -2. And that's when you go equally. We're dividing by a negative number. So what's going to happen? Our sign is going to flip. -2 divided by -2 is a +5. +1b, or just b. Now instead of greater than, now it becomes less than or equal to. We divided by a negative number, so the sign flips. And that's going to be, was it 6? Now we know that b is less than or equal to 6. Less than or equal to, we use brackets. And again, this is less than, this is greater than. Now, if you're not sure of which way, if you're not sure which way this thing opens, take a number, any number. It doesn't make any difference. Let's take 0. 0 is in our realm of possibilities here. And put it in for B. Is 0 less than or equal to 6? Yes. So we're correct. How about 10? 10 would be over here somewhere and not in our area. Is 10 less than 6? No. So we know we're correct. And our interval notation, negative infinities on the low side with a parenthesis, and positive 6 on the high side with a bracket. Mm-hmm. Mm-hmm. Okay. Now what about this? 5c minus 2 less than or equal to 3c plus 4. Now, it really doesn't make any difference here. Excuse me. But we'll move the variables first. That way you don't end up with some godless negative number. Okay, there's 5 C's and 3 C's. Which one do you want to move? Think about them like a load of bricks. Which one do you want to carry, 3 or 5? Let's carry the 3, it's easier. So we subtract 3C from this side, subtract C3 from this side. 5C minus 3C is 2C minus 2, less than or equal to, that's gone, 4. Right? Right. Everybody with me? Am I going too fast? Okay. Add 2 to each side. 2C less than or equal to 6. Divide by 2. We're dividing by a positive number, so our sign's not going to flip here. So C is going to be less than 3. Less than or equal to 3. Okay, 3 is here. Less than or equal to goes that way. And again, if you're not sure, take 0, plug 0 in for C. Is 0 less than 3? Yes. So we went the correct way. And our interval notation will be negative infinity with a parenthesis and 3 on the high side with a bracket. Okay? Mm-hmm. 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 Okay, let me do one more. Negative 5e minus 3. You can see now that we're going to divide by a negative number, so you can get ready that our sign's going to flip. Less than negative 18. I'm going to add 3 to each side. Negative 5e less than negative 15. Divide by negative 5. And you say equally. We're dividing by a negative number. So now e becomes greater than. That's going to change because we divided by a negative number. What is it, 3? Three is here. Now e is greater than 3. Greater than is going to be that way. Our interval notation will be 3 with the parenthesis and infinity. It goes on forever with a parenthesis. Mm-hmm. 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 Mm. Okay, this is about as difficult as these get, and that's if you have a compound inequality that is 8 less than or equal to 2x plus 4, which is less than 12. Now look, you have 3 sides here. Whatever you do to one side, you have to do to all the sides. So we want to get x here by itself. So we're going to subtract 4 from all the sides. And we get 8 minus 4 is 4, less than or equal to 2x, less than 8. Okay, now again, we want to solve this for x. So we're going to divide everything by 2. And we get 2 less than or equal to x, less than 4. Now this is where...
If we're dividing, the signs wouldn't switch.
No, because why not? Because we did not divide by a negative number. Yeah,
it's only by a negative.
Right. Thank you for asking. Right. Everybody understand that? Whenever you multiply or divide by a negative number, let me see, where did I have it written down? Somewhere in here. Down there somewhere. If you multiply or divide by a negative number, then the sign flips. But here we did not do that. We divided by a positive number, so everything stays the same. Now look, now this is where, when you think of x, x is greater than or equal to 2. And x is less than 4. Okay? Okay, so x is greater than 2. Here's 2. Greater than or equal to is that way. But x is also less than 4. Just these numbers right in here. Now our interval notation, again, mimics the graph. So what's on the low side? What's the least this number can be? 2 with a bracket because it includes the number 2. And what's on the high side? What's the most it can be? 4 with a parenthesis. And this is about as difficult as they get. Let's use some negative numbers. Negative 12 is greater than or equal to 2x minus 4, which is greater than, no, wait, I'm sorry, negative 2x minus 4. So now what's going to happen here? We're going to have to end up dividing by a negative number, so all of our signs are going to flip. Let me rewrite this. Negative 12 greater than or equal to negative 2x minus 4 greater than 8. Okay, the first thing we want to do is we want x over here by itself. So we want to move the negative 4, get rid of addition subtraction first. So we're going to add 4, and we have to add 4 to all the sides, not just one. Negative 12 plus 4 is a negative 8, greater than or equal to negative 2x, greater than 12. 8 plus 4. Okay? Now we're going to divide by a negative number. And you say, equally. we're going to have to change all the signs because we're dividing by a negative number. Negative divided by negative is a positive. Now instead of greater than or equal to, it becomes less than or equal to x. And again, we're going to change this one too, from greater than to less than, please think, -6. 12 divided by -2 is -6, I think. -5, and there's -6. Now remember, we want to know excuse me, from the perspective of x. X is greater than 4. I'm sorry, greater than or equal to 4. Everybody got that? X is greater than or equal to 4. Okay, so x is greater than or equal to 4. It's that way. And x is less than -6. Okay, now our interval notation here is going to be this. First we do this one. -infinity to -6, both parentheses, and what is that? Oh, 4. Greater than or equal to all the way up to infinity. This is called the union, kind of like a horseshoe or the letter U, because it includes all these numbers. Okay. Let's look at union and intersection. This is union, which means all of the numbers in either set of numbers. And the other one is the intersection. I just imagine union means or whatever numbers are in either one of these sets of numbers. The intersection, just think of the intersection out when you're driving. I don't laugh at my drawing. Where's the intersection? Right here. The intersection of a set of numbers is only the ones that are in both or on both roads. Let me do this. If we have A union B, and A is the set of numbers 1, 2, 3, 4, and B is 2, 3, and 7. Now A union B means the numbers that are in either one of these. So A union B is 1, 2, 3, 4, and 7. You don't need to write the 2 and the 3 2 times. Okay? Now, what if we have A intersect B? In other words, which numbers are in both sets of numbers? Two and 3, right? It's like we have 1, 2, 3, and 4. And on this street, we have 2, 3, and 7. So which ones are in the intersection? 2 and 3. This is not super whiz bang important, but you are going to see this occasionally. Mm-hmm. 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 Okay, what if A is 1, 2, and 3, and the set of numbers B are 4, 5, and 6? Okay, A union B is, in other words, which ones are in both sets of numbers? 1, 2, 3, 4, 5, 6. And what does A intersect B? Which ones are common to both of these? None. This is called the null set, or you can say 0 with a line through it. I don't know what, I think I told y'all earlier in the year, do not use this 0 with a line through it for the number 0. And this is why. Because 0 with a line through it means something different. Back in the day when computers and printers especially were not particularly good, they had to distinguish between, the number 0 and the letter O. And that's what they used to do back then, but that doesn't have to. So what does that mean? That, oh, and these things, these are called elements. Again, not particularly important, but you are going to see it from time to time. Mm-hmm. Y'all had enough? Y'all want some more? What are we supposed to be doing tonight? Oh, I don't have my syllabus. Stupid boy. Okay, we'll do absolute value and whatnot next Tuesday. Any questions? Don't everybody answer at once.
No, I think I'm good.
Y'all good?
Yeah.
Okay, I'll send you a copy of this. I did remember to hit the record button, so. Okay, y'all have a good weekend. I'll see you.
Thank you, Professor. You
Thank-
too.
Thank you. Y'all
Bye.
take
Bye,
care.
Professor.
Bye-bye.